Sounds good to me.
Okay, good. Apparently with the headset it didn't work. So I have to apologize for background noise, if any. So we are now at the top of the hour, so let's get started. Welcome everyone to the Think to Think research group, this pre-IETF 113 summary meeting. So we are not planning to meet at the IETF face-to-face meeting, so instead we're having this meeting, summary meeting before the actual IETF week. So my name is Ari Keränen, and Karsten Borman is also the co-chair of the group also in this meeting. This is an Irtf meeting, so the usual note will applies. If everything goes as planned, you are being recorded. Please be nice to each other, and the IPR guidelines apply. For more details, you can check out the following 2 slides in the chair slide deck, but I think most of you are already quite familiar with them. A quick reminder about the goals of the IRTF. So here in IRTF, we focus on long-term research issues that relate to the internet. So we do actually make research here instead of standards, although we do work very closely together with the IETF, where the actual standardization work happens. Here, really the primary goal is to promote development of research collaboration, teamwork, exploring research issues related to internet protocols, applications, architectures, and technology. Quick administrative issues. We have notes at the URL that you see on the slides today. Please go ahead and join the Etherpad, well, CodeMD nowadays. We also still have a Jabber channel that is connected to the Meeteco chat. You can also use the Meeteco application to join. And finally, if you're not at the mailing list already, please do join it. That's where you will get the announcements of the latest activities, and a lot of the discussion is happening at the mailing list. And as usual, we do have GitHub repositories for all our meetings. You have the link to the repository of this meeting as the last bullet on the slide. Then to the agenda of the meeting today. We are not right now in the introduction part of the meeting. We'll give a quick update on the current status of the research group, and then we'll also give reports from the WISHI and other activities. After that, we'll go to the main part of the meeting. We have a half-an-hour session around security considerations for constrained RESTful environments, SecCore, a new Think to Think research group activity. We have had quite a bit of work on IoT security before, but this is going to be a more focused set of activities happening, and Göran Selander will give you an overview of that. Then a particular item related to that work, Jon Matsu will be presenting amplification attacks on IoT. After that, we'll have a research talk from Savio on security extensions for using MUD to give fast response to new vulnerabilities on domestic IoT networks. And then we have a couple of updates from organizations that we have close collaboration with. So Michael McCool will talk about the W3C Web of Things, and Michael Koster will give an update on the 1DM and IoT schema. Then finally, Karsten will give you a quick teaser on the sworn work. And finally, around 1700 UTC, we should be able to wrap up and at the end of the meeting. Any questions or comments on the agenda? Okay, then going for the update. So we have had usually the WISHI activity by one monthly meetings or monthly meetings depending on the occasion, where we look at these interoperability aspects on semantics and hypermedia, and we're planning to start a similar meeting series around SecCore. So as I mentioned before, we don't have a Think to Think RG meeting planned at the IETF face-to-face. Instead, we have this summary meeting before. We have had a set of online meetings earlier with different SDOs, for example, W3C with OMA. but also very much looking forward to have similar meetings with other alliances and in particular open source communities. So if you're interested to have such meetings together with us, please go ahead and approach us chairs. Very happy to work together with you. Also, we are thinking of having a work meeting. So whereas this meeting is a summary meeting where you mostly hear about the updates of various activities, we're planning to have a work meeting where we actually have more of these research-focused discussions, and currently planning one around April-May timeframe. One particular topic that came up recently is this digital twins and how that would relate to use of IoT technologies. So please stay tuned. More information about that coming soon. Also, we are always very keen on having co-location with academic conferences. We had one recently online, and doing, for example, another one online this year, or maybe even face-to-face going forward. That would be very much in our interest. So if you're participating in one of the organization committees of such conferences, please do approach us chairs and let's have a chat. And also, we've been having only physical meetings for quite some time for obvious reasons. Very much looking forward to have a face-to-face meeting, also something very soon. So perhaps one of the upcoming IETFs or perhaps a work meeting. Then quickly, update of the current research group documents. So RESTful Design for IoT document got a minor update just a few weeks ago. Mainly on put method use of side effects and also addressing some of the chair review comments. There's a plan to have a bit more substantial PRs, pull requests on GitHub on some of the bigger issues from the chair reviews going forward. And then the idea is to move towards research group last call. Edge and IoT got a bit more substantial update recently, and now it's waiting for chair reviews and also research group last call coming hopefully very soon. Then we have had a quite long-standing process on the secure IoT bootstrapping draft that is nowadays known as terminology and processes for initial security setup for IoT devices. We didn't have an update for this meeting, but I checked with the authors and they said that work is still ongoing and we can hopefully get updates on that also soon. We have a few other work items that are not currently research group documents, but we're ramping up. One is this IoT information model standards description, and there's a related work on semantic landscape that has been discussed earlier in Wishy, and there's probably going to be a new draft coming on that topic soon. And also, we have had this IDEV-ID work on the root of trust security work from Michael Richardson. And for that, we actually got a review quite recently. It hasn't yet been posted on the mailing list, but it seems to be raising interest from different people. So we look forward to also to progress that work. And finally, we have had in the Wishy context quite a lot of discussions, and there's a plan to make potentially research group documents on some of those, what we call now Wishy notes, for example, around terminology. Then a quick update on the Wishy activity. So a lot of the work related to Wishy has been recently happening in the ASDF and 1DM context. So where in Wishy we look at this hypermedia and semantic interoperability, lot of those topics have been now discussed in those two fora. We did have one meeting in November where we discussed Web of Things topics, in particular how Web of Things thing descriptions and thing models relate to SDF, how this technology can be interworking together. Also, we have been discussing IPSO model, SDF, DTDL interwork and make an implementation of that, how we could bring in these multiple data model technologies together and demonstrating how they can be nicely working together. Currently in the Wishy work, we do plan to continue probably around the SDF topics mainly, but if you have any other topics you would like to bring around semantics and hypermedia, please do approach us chairs, and we're more than happy to take the discussion with you. So that was the quick update on the research group status. Any questions or comments from anyone? Okay, hearing no questions. Next, it would be Göran and Sekore.
Hello, can you hear me?
Now your slides should be coming up.
Can you see them?
I can see them and I can hear you.
Thank you, Carsten. Okay, so I'm Göran Selander. I'm going to talk about this new topic series for Thing2TRG, which we called SecOR, which deals with security for co-op-based applications, or more generally, constrained RESTful environments. We tried to find some good name here. CoreSec was apparently taken and has multiple meanings. SecOR turned out to be an Italian word, or at least understood by Italian as meaning dryness, the property of being dry, which seems like a good name for a topic dealing with security. So that's what we went for. And this, so there has been a series of planning meetings in T2TRG, and we've discussed a little bit of the content and the forms. And this presentation is my take on the outcome. I don't think we have converged exactly on meeting schedules and topics, but so anyone who participated in the planning meetings are welcome to raise their voice and comment, and as it's anyone else, of course, if they're having comments. So this work actually started with a breakout meeting at the core working group IETF 113 in November, where we realized that we need to do more work on security for co-op-based applications. And this slide is just showing that we do work already on security for co-op applications. Here are two examples. So we do work in the IETF, like in the first example is a recent RFC looking at security enhancements for co-op. One example is on the top right-hand side, the echo option, which is used for anti-spoofing and freshness. There are also other work in ACE and Lake and COSI and so on security related to co-op applications. But there is also work done outside IETF, which is used results that are needed by the IETF. And there's the second example here, which related to a problem that appeared with co-op group communication. So that's the example on the bottom right, where we have a multicast co-op message, or a co-op over IP multicast, for example, which is signed, and where the response could either be a signed message or a MAC'd message. And in particular, in the case when there is a unicast response, it certainly makes sense to just have a MAC targeting the sender, the client in this case. So in that case, the question that appeared was, can we use the same public key? So the client public key would be used by the server to verify the signature. Could we use the same public key for creating a shared secret with the client and derive a key used for the MAC? And is that secure? Basically, that was the question. And this was proven by Erik Thormarker in this it's a reference here to a proof. So that's an example of a result where we needed some research to advance the work in the IETF. In this case, the group security for co-op. I should just add to just clarify this picture that encryption is also included in both ways. So this is a simplified picture of what actually happens in the group communication. So with this in mind, we started to think about we need to do more work on security for co-op-based applications, and this could example be topics that are not in scope of a single working group, or an IETF working group at all. But we could see that there is plenty of space in the T2TRG charter to actually form a security research group for IoT. So, so the rationale here is that we think there is a need for a space where we can gather researchers and other people who are interested, and to progress the research as one important item, but also to explain the results for those interested but perhaps not experts in that particular security area. And these results can then be reported also at the summary meetings like this meeting. So that's basically the setup for and the motivation for this work. The type of results that we expect is specific research papers or preprints. It could be surveys, so which there already. I mean, there is already an example of that, the T2TRG-RFC on IT security. Or it could be that we are discussing topics spanning multiple IETF working groups, which doesn't have an established home. And there's an example on the next slide. And as Ari pointed out, the work in this should be related, of course, to somehow to IETF work. And here is, I wanted to write candidate topics, but that's not, I didn't want to do that because there are some of these drafts are adopted in other working groups, and this is not intended to be a competing activity. It's a supporting activity where we collaborate with working groups and we try to solve problems that doesn't have any other home, basically, where we can work on them. The two topics are highlighted. I won't go through the list here. We can come back to that if you're interested in any particular topic. Two are highlighted or boldface, and those are topics which we think we could work on short term. And one of the topics was already prepared for today. So we've also in this group started to think about how to group topics in short, mid, or long term, identifying what Karsten is calling a pen holder, maybe a good name, secretary, a person that actually doesn't have to be the one doing all the job, but is preparing the topic and providing the starting points, or at least some starting points for discussion. And yeah, so that's basically the ideas. I don't think we have a strong view yet on how frequent these meetings should be. Bi-monthly was a proposal. I think it needs to be driven by the people by the interest, basically, who are interested in driving, who are interested in finding solutions and formulating the problem statement that we will have as a starting point. We have a first candidate topic coming up now on amplification attacks. There is a second candidate on firmware update using multicast, but other proposals are welcome. Any comments or views or ideas on what we could use these meeting series for?
Yeah, I didn't want to impinge on Joran's segment here, but if we have time at the end, I will have a quick teaser for something that's called Swan and maybe will be called Tina. So that's something that's not directly sitting on top of CoAP, but it's also a security consideration in working with constrained devices. So we don't need to be extremely sharp in distinguishing things that don't fit and distinguishing things that fit. So, for instance, what I'm going to present has a lot of interactions with who are the actual players in a security protocol and how do you set up IoT environments. So I think it's more important that we get interesting conversations going between researchers on one, and of course between themselves and also between protocol developers in the IETF that want to make sure that the security concepts they come up with actually are supported well by research.
Okay, thanks, Carsten. And Colin, please go ahead.
Hi, can you hear me?
Yes.
Yes. Okay. So this seems not unreasonable, and that there's clearly some research things here. I think my only caution would be looking at this topics for inspiration slide. There's a lot of IETF work, so make sure you understand the boundary between what this group is doing and what the IETF is doing, and try to stay on the research side.
Thanks. Yeah, that's a good comment. We actually had the discussion in the planning on the boundaries to working groups, to IOTOPs and CFRG and other things. So yeah, so that's clearly something to think about. I mean, in this case, the boldface highlighted here are not identified as IETF working group topics. So those are, I think we are safe, and most of the other drafts are not adopted, and which means that they haven't found a home. But that's why I just want to call these topics for inspiration. This is not intended as a list where we are taking things which already have found a home working.
Yeah, and all this seems entirely reasonable. I think, yeah, and the things which you've highlighted also seem reasonable. But yeah, as I say, just be aware of where that boundary lies.
Thanks.
Great, thank you, Colin. And for everyone, I mean, if you want to join the comment queue, there's the hand raise button in the top left corner of your Meetigo, so you can use that to join the queue. Meanwhile, Göran, what should be for everyone who is interested in joining this work? What should be the right way of going, getting involved? Should they wait for the first meeting? Or the following meeting invitation, or should they contact you directly, or what do you recommend as the best way to get involved?
Yeah, that was actually my question going back. Do we need to plan anything more? Or should we just get started, send out invitations, and based on that, see if more people show up and have proposals? What we did was we had this slide here where we said that if you have a topic that you think is relevant, why don't you just prepare these type of think through these starting points here and come back, send an email to the T2TRG list and say I have a proposal. I think that's, I mean, it's fine if anyone wants to contact me personally. That's excellent, and using the T2TRG list is fine. Showing up at one of these meetings when we discuss these topics and say and mention new topics. I think that will be a sort of recurring point on the agenda for these meetings. What's the next topic? What do we have any new topics in mind, and so on. So yeah, just interact in any way that you find easy.
Yeah, so just in terms of logistics, these would be organized as T2TRG meetings with a focus on a particular topic, right? Which happens to be the SecCore stuff, right?
Yep.
Yeah, okay. Yeah, just make sure they get announced in the usual way, so they're in the data tracker and everything.
Mm-hmm. Yeah, that sounds reasonable. Okay, then I'm done. And the next thing is the first T2TRG topic. So John will present the amplification attack.
Thank you, Göran, and let me switch the slides. Your slide should show up any second now.
Yeah. So this is one of the topics we suggest should be handled as sec core. It was recently discussed in core, and the suggestion was that this would fit better in thing-to-thing-RG, and after thinking about it, I totally agree. So this short presentation will just give an overview, and the presentation is about amplification attacks, but I think SecCore should probably work with denial of service in general. So distributed denial of service is a huge and costly and growing problem in general. It has been growing, and you can do quite many different denial of service attack. You can do something smart based on a specific protocol, such as the TCP synflood attack. So you try to drain the resources of the server. You can compromise a large number of IoT devices and then send just any garbage data to a victim. And then you can do amplification attacks. In amplification attacks, you send a small message to a server, but you spoof the IP address, and then you get a request that generate a large response. And the difference between what the attacker send and what reaches the target is the amplification factor. This presentation and the draft we recently submitted exemplifies amplification attack with CoAP. Doesn't mean that CoAP is worse than other protocols, but there has been some significant amplification attacks with CoAP in recent years. And they likely used CoAP and NoSec. Luckily, the number of NoSec CoAP servers on the public internet has actually gone down quite drastically since I presented this in July 2021. And the big CoAP attack started in 2018. The biggest attack reached 320 gigabyte bit per second. This is a very large denial of service attacks. At least it was in 2018. Then in 2019, the attacks totally stopped. And quite little is known on what actually happened. Most of the reports are a bit misleading and strange. But I think we can conclude that they did happen, but not how. It seems like CoAP amplification attacks made a return in late 2020 and 2021. And I say likely because it's highlighted in this Raspberry report, but the report used the same color for CoAP and memcached. Looking at some other table in this report, you can see that memcache is listed as 1 or 2 magnitudes lower than CoAP. So it was likely CoAP, but it's you can have reasonable doubt. At least they seem to have disappeared again for the rest of 2021. I guess this is quite, you can see with the other attacks here, they come and then they disappear because the attack was patched by the device or they found something better. So very high level different types of amplification attacks that you could do with CoAP. Simple is that you just send a get, you get a match, and you spoof the source address. The server answer with something much bigger and sent it to the spoofed address, which is your target. This can be seen much worse when combined with observe. In observe, you send also a single get, but the server will send you n responses. To the amplification factor will be a times n. It's very similar in multicast. Here, each server will only send a single response, but if you have m servers, the amplification factor will be a times m. And the server, every single server typically doesn't even know what the factor m is. Typically, this get cannot be sent from the open internet to a local network, but you might be able to compromise a node in the local network and then use multicast to get out of the network. And if you combine, and you can also use it to attack some service on the local network, not on the public internet. If you combine them, multicast and observe, you obviously get the amplification factor of a times m times n. And whatever a and m and n is here, it's big. A reasonable amplification factor that Quick recently. So IETF has tightened the requirements on amplification factors. Quick recently which was published recently, must not have an amplification factor over 3, which is a very hard requirement. But this can be seen as best practice for non-constrained devices. So denial of service is a major problem. We don't want this, of course, and it's also a bit unacceptable that critical infrastructure has to take the cost for too much cost saving in devices. IETF should make sure it's not worse. If we don't take care of our denial of service hygiene, probably nobody else will either. And if the industry doesn't take care of this, then probably regulators will step in. And if they do, we want them to have an IETF or Irtf document to read. We also think this is a perfect topic for Thing2Thing RG SecCore. We need to raise awareness, increase understanding, and hopefully find some suitable mitigation suitable for constrained devices. And I think this topic should handle denial of service in general, not only amplification attacks. And that's it, I think.
Great, thank you, John. Any questions, comments? Please join the queue. Carsten, go ahead.
Yeah, I think the interesting observation in this amplification environment is that, of course, the amplification only becomes a threat if somebody actually uses it, and the interest in the community of attackers is highly variable. There are fads. People suddenly detect the ability to use NTP, and then they use NTP for a while, and then they start using DNS because people are becoming better in protecting NTP, and so on. So understanding the dynamics of the attack community is certainly one questions where we could make some progress, better understanding what's going on, because it's really not a property of the protocol that is of interest here. That really is when is this actually we're getting started to be exploited. And the other observation is that, of course, protocols can be deployed in different ways. And some of these deployments are more vulnerable and some are less vulnerable. And actually the CoAP standard contains security considerations telling people to not deploy the more vulnerable cases. but these deployments did happen. So why did they happen? Was this essentially just a lack of communication? Did people who were planning deployments don't know about the problem? Or were the requirements that we put there, were they actually not requirements that people could follow? So there was disincentive following the requirements because that created operational problems or something. So this is again something that is very hard to assess from a distance, and where we could really benefit from research. I mean, people can go out and try to get interviews with people who are running these deployments and so on. This is research that would be really useful. And that's information that then would guide us in understanding what we actually can do to make recurrence of this less likely. So for instance, the quick mandate is interesting because it's very hard, it's very measurable. You can write an interop test for that probably. So yeah, what are the best ways to incentivize implementers and deployers not to create these vulnerabilities? That's, I think, then the next step once we understand the motivations on both sides. Thank you.
Sorry,
Mike, go ahead.
So, sorry, could I just ask Carsten back here? So, on your comment, what do you see as, what kind of input do we need? I mean, you gave an example there on research, but who do we need to involve to get the type of data that you requested? How do we progress this work in that direction that you proposed?
We can come from various angles here. So of course there is an existing community that examines the DDoS space. So talking to those people will be of interest. We know of the various open source implementations. So this may be a channel to actually talk, to find and talk to people who are deriving their implementations from these open source implementations and who are building applications around it. And then, of course, from the DDoS research, we might find big deployments that we want to address directly. So that there was this one deployment that initially was responsible for almost all of the servers with a high amplification attack. And it would have been interesting to try to find these people and talk to them, do interviews with them. Of course, there are limitations to all these approaches, but I think in total they could generate some useful information.
Yes, indeed. I think that would be great. But how do you see as the next step? Do we have people we should invite, or are there sort of research projects we could fit into, or master thesis, or what would be the next step?
Yes.
Okay, thank you.
I think we need to do all these things, and I think starting with the DDoS research community and actually finding out the structure there and finding people who are interested in this would be a good step to move this forward.
Good. Who should talk to the research DDoS community?
Now there we are at the penholder issue again. So somebody needs to push this forward, and that's probably someone who already has a little bit in the way of channels talking to research communities. And yeah, of course, doing master thesis in this space and so on, these are all also very, very useful, because there's a lot of information out there that we haven't gathered yet, but I think actually talking to the people who do the investigations in this space would also be very interesting.
Okay, is there any? Sorry, Michael, for keeping you waiting. I just wanted to sort of nail down this one. Is there anyone that is interested in going forward and addressing research community in this on these questions, or maybe they already have experiences that can be useful already now, that we could sort of base some of the input here.
So let me just give an example. So, for instance, we have pretty good connections to the Riot community, which is really an operating system in the IoT space. But in the Riot community, there are people who actually are looking at vulnerability to attacks and so on. And gathering these people and having a special workshop, bringing the various views of these people together might be a first step to get them interested in the subject.
Okay, good starting point. Thanks. Sorry, Mike.
Okay, now Michael, please go ahead.
Yeah, so I mentioned one use case. We've been working on discovery, and we've been taking an approach of a two-phase strategy where we have an open mechanism that's kind of on ramps, and then we do authentication, and then we act as metadata. But your talk made me realize that the onboarding of the on-ramp mechanisms may themselves, result in application attacks if the data they return is greater than this threefold factor. So it occurs to me we're going to have to look more carefully at rolling back authentication to an earlier step in discovery if we want to avoid having discovery mechanisms be used for attacks. So I just thought I'd mention that use case, that I think we need to look carefully at things like discovery that are meant to be open, and sort of have to be to get started, but maybe we need to really nail down exactly how to minimize the information.
Yeah, I think important goal of this talking about the service in SecCore is to raise awareness. I think it should cover more protocol than just co-op. That was the example here. I think there's a lot of I think people don't realize that the protocols and systems can be used for amplification attacks. It's easy to forget that.
Michael, do you have a pointer to that, or is it just some sort of part of a project that you discovered?
We'll talk about discovery and other things later, and I'll return to this topic.
Okay, thanks.
Yeah, Michael Richardson had some comments in the chat about things we could document in a way that is useful for both protocol designers and implementers. So I think we should look at those suggestions as well.
That's good.
Okay, very good. I mean, good discussions and good input for the work. I think we have a good amount of interest on the whole area on security and SecCore going forward. So yeah, as Göran pointed out, please don't hesitate, communicating on the Thing2Thing research group mailing list more on the topic, and then look forward for announcements on the invitations to the meetings on that topic, and let's continue the discussions also there. Now moving forward, we have the research talk from Savio. Savio, please go ahead.
Yeah, and Carsten, thank you very much for the space and for the time. Here I'm gonna. My name is Savio Moraes. I'm Here I'm gonna talk a bit about the product of my master's research, my master's course research, which resulted in the draft Moraes IOTOPS issue, which focuses in coordinating fast responses for to new responsibilities in home IoT. Okay, was carried in the LabNet, which is the Computer Network Laboratory. I have made my master's in the Federal University of the Rio de Janeiro State here in Brazil. So going to the point, okay, the main problem, not exactly the main problem, but one of the problems that we have in home IoT insecurity now is that we have a lot of persons having small problems that can be joined in a big problem, as the DDoS problem or any other things with infected devices or vulnerable devices that can have data leaked from malicious agents. And for the end users, it's hard to keep protected from these new vulnerabilities, as every day one new vulnerability is discovered from the community, from the attackers or something like that. And the idea behind this project is to speed up this response in a community view, in a coordinated view for many home IoT networks. So one of the possible answers to this question on speeding up the responses for new vulnerabilities and attacks for home IoT is by using IDS or IPS solutions, but it's not exactly practical for end users, and it's hard to coordinating all this response. We always need some fine tuning. We always need to get new attack signatures or vulnerability signatures. And for doing this, we somehow need technical expertise for that, and the regular users that does not have it. And when we use anomaly solutions based in anomaly detection, we can have some scenarios where the device is the common behavior, the normal behavior of the device is profiled during one attack, during one infection, and also the profiling process has high computational costs, and maybe the current algorithms has high computational costs. And in some cases, we need to outsource this processing for cloud computing services or something like that. Also putting in risk the privacy of the end users, sending private data from my internal network to cloud computing services or to a technical expert, security expert, for analyzing and fine-tuning my rules in my home network. This is one of the points. And another answer, good answer that came from the IETF is the RFC 8520, the manufacturer usage description, or just MUD, which gives important tools for us to dealing with vulnerabilities in networks. And the first of all is that it in somehow reduces the possibility of one device being attacked or exploited by one vulnerability, as MUD provides means to a manufacturer, say to the network manager, which is the expected traffic for that device, and then it can block all the other traffic, which is not expected in the words of the manufacturer. And besides of that, we also have one important tool, which is also mentioned in the RFC, that is Mud gives some tools to us that supports the generation of supports us on building a graph of the network communication of our IoT devices independently of our topology. And having this graph in mind, or in our hand, sorry, we can identify, it's easier for us to identify threats, vulnerabilities, attack paths, or something like that, because we have one tool that maps all the communications. So this is also important, it's used in this proposal, in the proposal of issue. But the problem of MUD is that we still keep relying in the manufacturer. We originally only relied in firmware updates, software updates, security updates for that device. Now we have one security tool for giving a kind of coordinated response to a vulnerability. For example, a manufacturer can release a MUD file blocking the traffic that it's related to one critical vulnerability, but we are still waiting for the manufacturer or the device vendor. And not only this, the users keep using the IoT devices even when they reach the end of life. The manufacturer stopped to release security updates from the device. So we need some support in this kind of situation, not only during the life cycle of the device, but after the end of its life cycle. So the idea of Ensure, of the proposal of Ensure, is to give the support, this coordinated support, as a second security support for the ordinary users, the common users. So the Ensure, the complete name of Ensure is Inter-Network Exposure Analyzer Utility. Is a proposed framework to simplify the process of identification and classification of potential vulnerabilities and threats. So Ensure provides means to give fast and coordinated responses in a community view for new vulnerabilities in IoT. Not only vulnerabilities, but attacks and malwares, botnets, and so on. So for doing this, we have one architecture that where we do rely in one third-party support that are security specialists, security experts that provide some attack signatures of the ongoing attacks in a moment of time. But the fine-tuning process of these signatures is made by Ensure in the internal network by using the information provided by MUD. So we keep the end user privacy, as we do not need the third-party support on fine-tuning our rules, our attack signatures. All this works, all this process works by using knowledge sharing for the community protection as a whole, okay? And more than the whole community protection, we also have one protection for the whole internet community when we talk about, for example, botnets. So this is the architecture of Ensure. We have basically integrated the whole functioning of MUD, and as the output of MUD, we have the communication graph of the network, and then we use this output from MUD to process with issue. And we have also the malicious traffic, malicious traffic description file, which is provided by the security authorities, the security experts, to the home IoT networks, that will contain the attack signatures, and in the border, in the edge of the home network, we will process this information and identify and assess potential threats in our network by comparing the signatures of malicious traffic, of attacks and malwares, and the actual traffic that we can have in our network, which was provided by MUD. So we also proposed in this draft the malicious traffic description data model, which is an Yang data model, strongly inspired in the MUD data model, where we use access control lists for describing the attack or a malware signature, the whole traffic, for example, a common network service. So we use the ACLs for describing the traffic, but we also have the context information in these signatures, which describes the conditions, the scenarios where the combination of exposure of vulnerabilities can become a real threat, a real risk where someone can exploit it for carry on one attack. So this is basically how do we describe the two kinds of malicious activities: isolated attacks and malwares, where we separate the both things, because attacks here we understand as one single attack, not coordinated attack, carried by only one person exploiting one or two, just a few vulnerabilities, as for example, someone brute forcing the SSH of my CPE, for example. And the malware description is a way more complex and has much more complex information with combination of critical traffic that can become or not malicious, risky, sorry. So in each attack or malware is defined by one or more ACL, access control lists, and this ACL has one risk threshold. This threshold will be used to compare with the exposure that we identify in our network by summing, by adding the value of all exposure to the malicious traffic that is associated to one access control entry. So each access control entry that describes, for example, the telnet the access to a telnet port has one integer value associated, that if there exists one exposure, we sum all this risky exposures and then identify is that ACL is risky or not. And also in the scenario of malwares, we have combination of risky ACLs, which here we mention as critical ACL sets, that when we have this combination of critical ACLs, we indicate one action to take when we identify this combination of critical ACLs. So the process starts with the network communication graph provided by MUD. So we get each one of these links. This is just a visual tool that the Mud Visualizer provides us. Just to give an example, a visual example for you. So each one of these links is compared with each one of the access control entries in the MTD file. And then the first phase of the assessment of threats is on identifying the exposure of vulnerabilities. So we compare source and destination IPs of that link, of that communication, with the access control entry, the protocol that comes in the sequence, if it is ICMP, UDP, or TCP. In case of in TCP communication, we can specify this TCP initiator, the transport, in case of transport header, TCP or UDP, you will compare the source and destination ports, and in case of ICMP, the type and the code of the message. Nothing exactly new, but after identifying a complete match of communication link and malicious traffic description, we will combine all them for assessing the threat, the exposure, assessing the combination of exposures to understand if it is a real threat. So we will sum the risk of the exposed ACEs, access control entries, in the context of one device and one access control list, and verify if we hit the alert or risk threshold, and when we hit his threshold, we will go to the second phase of the decision. This that is specifically assessing the threat, where in the context of isolated attacks, we just block or suggest to block, depending on the implementation, that link, that communication. Or in the case of malware, we will see all the ACLs, that access control list, that are in the context of that malware, and verify if we have some combination of critical ACL sets as a risky combination, as a critical combination, and then take the action that is indicated in the malicious traffic description. And then when we identify, we can see which links we can block, simple links, and broke the chain of the attack and reduce the risk of threat. So we have carried some experiments, in vitro experiments, for comparing the protection comparing the protection of MUD and Ensure, and also in one network with no protection by using one Mirai variant. I don't think I have time for explaining this experiment, but we had really good results with Ensure, where, for example, while we were using MUD, we still had generation of DDoS packets in a private network, and while in Ensure we did not have any generation. MUD blocked almost every traffic, but Ensure did not generate anyone. So I can go ahead, but basically Ensure blocked all the traffic that we described, and this is the relative gain that we had of Ensure over MUD. We have one paper published with these results, and maybe we can check it later. But the next steps that we have now is for using Ensure as one optimization for anomaly detection algorithms, as we initially tried to make Ensure be an IPS itself, but it will probably have a big impact in the usability by blocking critical communications based just on in the risk. So we understand that maybe issue can be improved by using its output as a filter for the input of one anomaly detection algorithm, and then we are planning to test with different approaches for profiling device traffic and identifying these anomalies. Uh, and about improving the issue proposal itself, the draft itself, we currently are still working in the transport layer, but considering what we had in our experiment, we saw that we still can exploit DNS traffic even with the deployment of issue. So we are planning to go to the application layer only for protecting DNS, and also deploy and test issue in the real world for measuring the impacts in usability and see other things that we can improve it. And we also have one ongoing undergrad thesis being developed in the Federal University of Rio de Janeiro on a collective approach to profiling one malware with the same idea of keeping the end user private even when we share data of our traffic, but we are still trying to find some ways to share this information and keep privacy of my network. And the final output of this research, the idea is to have the automatic generated of malicious traffic description files. So that's all for now, but I'm open to listen to any comments or questions. Thank you.
Great, thank you, Savio. And for anyone who would like to learn more about this topic, I guess reading a draft and having a look at the related research paper, are those the best sources?
Your question. Can you repeat, please?
Yes, no, you should be able to talk. Yeah, so my question was, like, if someone would like to have a bit more reading on the topic, you have now a link to the draft on the slides. I guess also we could put a link to the research paper that you had on the topic that people can have a look at that. Would that be the best sources for more information?
Yeah, and I can also share with you my master's thesis, which describes more about it. So you can have it also. But I don't have a public link from the university, for example, for this thesis. I can share the file.
Okay, thank you. Carsten, go ahead.
Yeah, I like the offer of sharing your master's thesis. So that could go into a collection of documents that we collect in conjunction with the SecCore activity. But I have two questions. One very specific to your slides. You went over slide 13 a little bit quickly. So can you quickly explain what these two-letter? Can you go back to slide 13 and quickly explain what these two-letter things were? I'm not sure I understood that.
Understand. Which slides?
13. 1-3. Yeah, this one. So you have CB and I and SN. What are those?
The meaning of controllable bots is the number of bots that really were connected with the command and control of the Mirai botnet, the variant we use it in the experiment. So how many bots really connected to the command and control server?
So the first two items we can see here is that normally more than 100 nodes go into the botnet, and some 20, less than 20 are infected. And when you switch on your mod implementation, you only have 40 who join the net, and almost no one is infected. Do I read this right?
We had some scenarios where we started with, in all the scenarios, we had at least one device infected, but in this, we had 112 bots in the experiment. In the paper, in the thesis, I explained better this number, but this metric, the CB, we get from the really connected device to the server. So even with the device infected, if it starts infected in the running of this experiment, it cannot connect to the server because some solutions block. So for example, in the second scenario, from the left to the right, where all the devices were infected, but mud was deployed, mud-based rules were deployed, only 40 or I think that was 40 devices could connect, even infected, could connect to the command and control server.
Okay.
While, for example, in the same scenario with the issue protection, if you go to the right, the first one in the extreme right, all the devices were infected, but no one of them could connect to the command and control server.
Michael, do you want to ask on this point? I have a different point, and I don't want to lead this discussion astray. So if you want to ask now.
That's a different point.
Okay. So my second point was you now have these MUD files and the malicious traffic descriptions and so on. And of course, that to be useful, this needs to become a pretty sizable collection of data. So do you have any idea how you would want to organize cooperation with other groups on sharing this data? So there is, for instance, this group in Australia which has collected a lot of MUD files, and I think it would be interesting to bring these data together and get a little bit of a synthesis between what we have from the various groups working on this. Do you have any idea how to do this, or do you want to help doing that?
The MUD files that I used in the experiment were the ones that was provided by the group in Australia. So the networking started there. But yeah, I can share the malicious traffic description file, and I also have in my GitHub account the data that I collected from this experiment. If someone else can check it, and they can find some way to share all this information. But I think that in the draft I have put the as one example of MTD file, the example that I used in this experiment, based in this variant of my right. So it is all, it is public, but maybe we can find some other way to share it. I'm completely open for sharing it. Yeah.
Great. Michael. Michael is not
Michael, go
finding
ahead.
the unmute.
Winnie got buried. So I guess my question is: so you have a MUD controller that's running. I'm wondering what did you use? And since Mirai mostly has infected routers, and some DVRs, what were your actual devices that were vulnerable that you were using, and how did you protect them with your MUD control firewall?
In the experiment or in general terms in the proposal?
Well, you did an experiment, yeah. So I'm interested in
Uh,
what controller you used, and you wrote some MUD files, and not every. So far, I don't know anyone who's implemented all of the MUD spec. So I was interested in what you had, and then if I'm also, and if you actually were just using routers, which were home routers, which were vulnerable to Mirai, whether the MUD controller was running on them, they were protecting themselves, or something else was protecting them.
For the experiment, I have as I said in the slides, it was in vitro test. Like I used Docker containers with open telnet servers for simulating vulnerable IoT devices. So it was not like in actual devices. It was really in vitro, not like real traffic. It was just like the myriad traffic in the network. It was really in vitro.
Okay, so basically what you're telling me is you had containers running vulnerable instances with a telnet server running, and I guess this is some really old OpenWRT or something like that running inside of it, or and then your MUD controller was something you built yourself?
Meant really the mode controller. I have just made it by myself. The process that mud defines for using for creating the rules, and then I
Okay.
deploy those rules by hand with in the Open vSwitch, which was connecting the devices.
Okay, I understand. All right, thank you.
Okay, thank you, Savi, and thank you for the good discussions. We're now approaching towards the end of the this slot. So thanks again for the good discussions. Definitely let's continue them on the Thing2Thing Research Group mailing list, and also, of course, on the SecCore activity. I think this could be a good fit to be also discussed there. And now we have next the W3C Web of Things update from Michael McCool. Let me allow you to share the slides. They should be showing up any moment now.
Here we go.
Great. There you go.
So I will say I've got a fair number of slides here, but I will basically quickly go over things that people have seen before, most likely, and then focus on some topics that are more discussion oriented. So I'm just going to dive right in, but just be clear, I'm going to be flipping through some slides quickly, but the slides are available if you look at them afterwards. So, okay, what is Web of Things? We're basically trying to adapt web technology to IoT. And the gap we identified a while back was a lack of a common, narrow waist. And the ship had sailed to make that narrow waist a protocol, so we focused instead on common metadata to describe interfaces across protocols. And so we're kind of looking at, how to build the layer between protocols, not just focusing on one protocol. And the main deliverable, which is already published, is the thing description. We are currently on a second round, and we are looking at new standards, including one for discovery, which I'll talk about. Give me a second here. Okay. So yeah, that's what a TD looks like, and it's basically a JSON LD file, meaning it has semantic support. And in fact, in our discovery mechanism, we're looking at enabling Sparkle queries to allow full semantic functionality. I'm just going to skip through this and get to the meat. I'll skip this too. Just to say that we, generally speaking, can deploy TDs in different use cases. It can be, peer-to-peer devices. It could be cloud devices. It could be between two cloud services and so forth. So we can describe a range of different services. They could be individual devices, and they could also be services in the network or on the edge. Okay, so I want to do a bit more of a deep dive into this and discuss the point that I raised earlier about amplification attacks, among other issues. So, sorry, I'm going to constrain my pets here. So, so in discovery, we have a spec that is currently under review, and we're hoping to publish it later this year. And this spec is about, okay, we have this metadata format, how do I get it? And how do I get it in kind of an ad hoc fashion? And so we were looking at a two-phase strategy where we have introductions, and the introductions are kind of don't require authentication. And the second stage is exploration, and exploration does require authentication. And the general idea is to reuse existing mechanisms for introductions, including simply being given a URL, or having a beacon or UPnP or things like this. And then the output of introductions is a set of URLs, which then you need to access a service, authenticate, and then get full metadata for devices. So the challenge here, and then the exploration services, the second phase, can allow you to do queries and even things like Sparkle endpoints to do queries. We've also been looking at JSON path and Xpath. The trouble we're having is JSON path is not standardized yet. It's still in flight under IETF. So we're kind of waiting for that. But it currently lacks particular substring matching and regular expression matching, which we feel are important for filtering out TDs. Xpath is great and it has JSON support, but there's not a lot of industry pickup of it, and there aren't enough implementations out there. So we decided not to include it. And Sparkle is there, but it's relatively expensive to implement. So, so we're kind of waiting for JSON path to really make queries be, I feel that's like the right level. We also are still, we were originally going to be doing location-based queries, but we decided to defer that because we're waiting for some convergence on geospatial data. Anyways, so I have a link in the minutes about an issue about the amplification attacks, and we're probably going to have to figure out how to limit, introductions that return multiple URLs, and require. And I'm going to look in particular at core RD, which is one of the introductions that we've included. Probably require authentication if you have lots of results from core RD. Anyways, let me just plow through here. So we've been updating our scripting API. This is not normative, but we've been looking very closely at how to deal with things like discovery as well. And we also have various integrations with things like Node-RED that also support discovery now. I won't really dive into this, just these are out there and there's implementations of them. Node-WAT is an open source implementation that can consume TDs and then talk to them using the WAT abstraction, but it's not a normative part of the spec. We also have a huge document with lots and lots of use cases, and we're currently analyzing these to derive requirements for a further round of work on other things. And in particular, looking at things like MUDs, looking at proxies, how hubs work, LANs and onboarding mechanisms. So there's a bunch of things that are currently gaps in the WAT spec that kind of appear in some of the use cases, geolocation information. So we're going to be looking at those probably in a new round, but it hasn't been decided yet. But sometime in the fall, we're now finishing up this phase, and in the fall we'll be discussing, do we do another round, and if so, what does it include? So I would welcome comments on things that are gaps. I'm not going to belabor that. I will just mention that we have a bunch of links here if you want to do lots of reading. But again, the new stuff is updates to TD 1.1. We have a discovery, which is totally new. We have updates to architecture. And there's also the use cases document down there. We also have a brand new website that is trying to organize things better, and that's the last link. And the last link is the one you can remember because that has links to everything else. Next week, we have a Plug Fest. If you'd like to join us and play with Watt, you're more than welcome. Just send me an email. I'm also going to, in a minute, have a slide talking about some new applications and of Watt in commercial applications, actually, and also some open source projects. For discovery, we also have some implementations, at least 2 of which are open source and allow you to do queries of various types. And as far as IETF goes, a couple of major things. I didn't mention actually Json schema, which is actually quite important to us, but also Json path, and also things like core ID and COSE and ASDF. So we also have a thing model, and we're looking very closely at making that interconvertible with SDF, so the same information can be expressed both ways. Another relationship looking at closely is OpenAPI. So a lot of things described by Watt TDs could also be described by OpenAPI. But OpenAPI is sort of very targeted HTTP, and Web of Things thing descriptions are open to other protocols, including MQTT and CoAP. And we're also looking at BACnet and OPC-UA and other things like this. Anyways, we've also been looking at signatures to be able to nail down and constrain changes to Watt TDs. That's not in the current spec. We have a draft, but we need to align that with JSON LD signatures, which are in flight right now. And there's also geospatial data. I mean, we're working with OGC to try and get that aligned with their standards. Okay, so just to mention some applications. So Takanaka Corporation is a huge construction company in Japan, and they have been using Web of Things for building information systems. So for large commercial buildings, keeping track of all the various devices and presenting unified interfaces to them. And actually Siemens has a commercial product as well, does the same thing. So we've been looking at collaborating with the linked building data model and things like looking at the bot ontology and things like this, things which can work well with the JSON LD infrastructure that we're establishing with thing descriptions. So what thing descriptions can include extensions from other vocabularies to handle other kinds of metadata. And so you could imagine, for example, identifying what room a device is in, or what zone a control or a sensor affects, and so forth. And these are actually quite useful in BIM systems and in building management systems. Netzo is a startup out of basically from TUM University, TUM in Munich, and they are looking at creating dashboards and hubs. So the other place that Watt metadata is useful is to generate, integrated dashboards for a set of devices that you want to coordinate and have a nice single user interface for. Ditto is an open source project, which is primarily, however, being driven by Bosch, and is basically, a foundation of their commercial products. And they're focusing on digital twins. And I will say that Oracle is also involved in Watt, is heavily invested in digital twins, and has a way to interconvert between their proprietary digital twin model and Web of Things TDs. So there's also some activity around generally digital twins and having services that can shadow or provide additional functionality to IoT devices, or even just simulate them for testing. So that's the Ditto project, and that's available under Eclipse. Okay, so I guess I have like 5 minutes left. Let me just mention a range of things that we are thinking about doing next, and that we probably need some research on. So one, GIS integration. I didn't mention smart city applications. There's another group in W3C looking at smart cities. One of the things we needed to consider there is GIS integration, because very often in smart cities, you have to know where an IoT sensor is, what it's measuring, and you also have to look at things like historical data. So there's an IEEE group that's just started looking at standardized query mechanisms for time series databases and for geospatial queries. So we're very interested in, for example, extending discovery to be able to discover devices in a certain area, and how to do that in a scalable way. But that requires us to standardize the metadata for where a device is. Data management, digital twins, there's a bunch of patterns like shadows and simulation systems and proxies we need to figure out. And we have to figure out how to handle historical data, perhaps, and event notifications, like how often you get them, and whether you want to get notified if things are differ from past experience or whatever. Okay, however, I would say the biggest blocker right now for Watt is definitely security. So Watt wanted to replicate the success of the web in IoT. What does the web have going for it? It's got a common data format, HTML, it's got a common protocol, HTTP, and it's got a common security infrastructure for identity and keys, CA, certificate authorities. Okay, so in the Watt, we focused on standardizing the data format and describing protocols to get some consistency around the abstraction for protocols. Okay, but we don't have, and we have declared out a scope in our past work, is a common mechanism for establishing identities and keys and onboarding and all this stuff. And that's a big problem, especially on LANs and local networks that are segmented. So this is probably the biggest barrier right now. Watt can be used if you can depend on CA. If you don't have the ability to use CA, for example, in a segmented network, then you need some other mechanism which is currently out of scope for Watt. And that means that browsers, for example, don't necessarily work out of the box with Watt because you have to set up search and things first. So this is a big problem. I think it's also kind of something where we need to work with browser vendors to get them to adopt something that works well with IoT devices on LAN. And it's not really a technical problem. There are known ways to deal with this. It's a problem of getting the browser vendors on board and having some common system that everyone agrees on is the right thing to do. So that's something that's probably going to be another big chunk of work in the next little while. Also been looking at accessibility, mapping, input and output modalities, and doing things like having smart city services for mobility and so forth. Okay, I'm just going to stop there. I know I've gone a little long, but according to the schedule, I have a couple minutes. So yeah, maybe if we have time, we can take questions.
Yes, thanks, Michael. We have a few minutes for questions. Karsten, go ahead.
Yeah, I just wanted to thank you for this. I think this list of gaps is definitely a very useful piece for us, and maybe we actually should go into documenting in a little bit more detail what those gaps are. There is currently a discussion going on, I forget which mailing list this was, about doing PKI-like stuff with IoT devices that are in a home environment. So I think that will be interesting in this context. I'm sure Michael Richardson has more thoughts about that.
Yeah, and I think we need a good technical solution, and then we need to get it adopted by browser vendors. So one of the motivations of doing WAT is to use browsers as a user interface to IoT devices, right? But you can't do that right now, at least not easily, without having a lot of security set up, which an ordinary user will not do. So that's our biggest problem right now, and we need to get the browser vendors to buy into it.
Yeah, we would need to understand their incentive structure in this
Exactly.
space and build something that hits that incentive
Exactly.
structure. So that's not just a technical problem.
It's not a technical problem. That's right.
Okay, if nobody else wants to say something, I might mention that Xpath had an interim meeting yesterday, and we have a way forward for regular expressions. Now, you mentioned substrings. Do we need that when we have regular expressions?
Well, no, it's just that regular expressions are probably more than we need. So I sent in my comments already saying that we at least should have substrings. But if you do have regular expressions, that's great, of course.
Okay. Good. Thank you.
Okay. Thank you.
Okay. Thank you, Mike. Maybe one quick question, like to continue the discussions on these topics, what are the best venues? For example, for the SDF Web of Things interval, I think Wishy meetings will definitely continue that. I guess for the security aspects, Secore perhaps. What about for all the others? What do you think is the best way to continue the discussion?
Well, W3C has both interest groups and working groups. And so we're going to be now looking at, I think the interest group need to like explore various approaches in a non-normative setting. That's sort of more researchy. But at some point, we want to get to the point where we have something that we can work towards a standard on. What I think we really need to do is work on our use cases and get the business case and the incentive structure in place. And like I said, get browser vendors on board. But yeah, I think that SecCore may be useful, but I think what we really want to do is look at the actual requirements and look at existing mechanisms that are already out there and see what we can simply adopt and push forward. And ideally, it was pick something that's already been standardized and is something that is worth it while adopting as part of Web of Things.
Okay, great, thanks. Yeah, and perhaps we could take a session in one of the upcoming working meetings too, to explore these in more detail. But thanks a lot for the overview and very good good discussions. So now let's move forward to the 1DM update. So Michael Koster, please go ahead. So Michael, can you request the slide sharing?
Should I have a slide share? Hang on. How do I do this?
Yeah, it's the second button.
Yeah, I clicked
right
that,
next to
but
join queue.
what shows up? That screen request.
Yeah. Can you
I
try again the slide request? So the second button. Or if you wish, you can also share from your screen. Is that better?
Well, that's what second button. Slides. Okay.
Yeah.
Okay, that's fine.
Now.
Okay, great. I got it. That'll work better. Fine. Let's see. Where is it? There it is. Got it.
It should show up in a second. Yes, there you go.
Okay, it's there. You see it?
Yes, now.
My video works. Oh, it looks like my video is working too. Cool. Can you see the slides?
Yes, we can see the slides.
Okay, cool. So I'm going to mostly talk about 1DM and summarize some stuff, but also have a slide on IoT schema. So how do I advance the slides? Is that real obvious here?
Bottom. For each slide.
There you go. Okay, now there's a button at the bottom. Okay, so so where we are is we have a lot of contributed models from OM8 SpecWorks and OCF that constitute about 200 definitions in our playground. We have developed an operational process for selecting and converging and what we call adopting models, but this is a hard problem to to do, and what we've kind of come up with as a metric as midterm. Ultimately, we want everyone to be using the same models, but in the midterm, we want to come up with models that will mostly work for all the different device ecosystems. And we recognize there may be some corner cases, but this is what we're kind of shooting for as a midterm goal. So this is sort of where we are conceptually in the organization. And we really have great interworking between OCF and OMA demonstrated already with the converters. In fact, a little bit more about that later. And we've out of the process have come some requirements for how designs really ought to be structured to meet everybody's requirements from simple to complex without losing functional interoperability. So internal functional modularity is kind of what that looks like. How do we layer functions within a definition so that we can have a semantic thing that has some varying depth to it, and won't go too deep into that. But going forward, what we're doing, sort of the new stuff, there's a new mailing list. We're off Causeway now, and we're on groups.io. So you can sign up for that. It's just 1DM at groups.io. We are continuing to refine the convergence process, working toward how we create evolvable designs. And so we're recognizing we're probably not just going to be adopting existing designs, but rather adopting sort of refinements of those designs. And then what are the best practices around that to arrive at those results? Really great development, in my opinion. We've created bespoke repositories. What I mean by that is that as an organization or model developer, you can come in and create a 1DM repo that uses the CI tools, but doesn't have a convergence requirement up front. So only if you satisfy the CI requirements, you can basically publish models on 1DM in your own namespace. So we have these stable namespaces, and that's kind of the idea, is that from there we can build interworking and incremental convergence, much in the way that we've seen with OMA and OCF so far. And these are, will be public-facing models with common CI tools, but the content governance is loosely coupled. You could sort of have your own way of deciding how models get incremented and versioned until you start contributing to the adopted models. So if you want to figure out what that means a little bit more, come to our meetings and join up. We're adding more models from Bluetooth Mesh, and it makes it easier to do this. We're starting with the models they've already published and already using across the Bluetooth range. So that would be the characteristics and the data types that they've already defined, and we're going to publish SDF models for those, and then move up the stack, if you will, as we get composable models toward the Bluetooth Mesh. And those will be good examples of composable models because there's some depth of feature that we have there to work with. So we're working on how we compose models internally and reuse definitions semantically. That's an important thing for interoperability, and extending our models with linking and composing complex objects and this sort of thing. Also, one of our main goals is to do an SDF pressure test. And what I guess we've concluded, as we're ready to sort of go to the next step with SDF, that it's working as it's designed for the object granularity we originally intended. But of course, now we've got an expanded use case where we need to do some of this internal modularity, as well as complex objects and composed objects. And there are probably some more features there, but we think that even SDF as it is, we have an extension point that we can use to exercise new features that that will probably work pretty well. So, but we're working on coming up with some examples to validate all of that. But that, the things we talked about, the internal modularity, extension points for mapping to different things, so-called mapping files, complex compositions. And we find that interworking with other frameworks is sort of like complex composition in terms of there's some loosely coupled models for building up structure and system structure that are non-hierarchical that we need to think about. That's kind of a summary of where we are with 1DM, the high level points. One thing to point out, that bespoke repositories, we already have the 1DM and OCF separate repositories. So that model is deployed, and we're basically looking for more people now to be able to come in, and more orgs to be able to come in and build those. So for example, if we could re-engage with, well, what we're going to do with Bluetooth, for example, but then a couple of our earlier interested parties like Sunspec have gone off and created a bunch of Modbus register definitions that can be turned into one data model models now as well. Okay, and the last thing I wanted to just sort of summarize, people might be wondering what's going on with Iot Schema. We haven't had a meeting since last August. Basically, just to refresh everybody's memory, we were building an RDF framework. We are building and really built it for this event action property meta model to come up with definitions. So it's essentially what 1DM and SDF does, but we were using RDF there. And there's a good set of definitions there. We've been playing with those with W3C and the linkage using what we call semantic annotation to say that, oh, this data set here corresponds to the control of a light switch, and then we can sort of link that back semantically to the IoT schema definition of a light switch and describe its affordances connected to that semantic definition of that sort of is meant to cover all light switches. That's kind of the idea of IoT schema. So we're compatible with W3C. It's been used in Plugfest. It seems like a good pattern, but we really didn't get the engagement of people to create models. So that's kind of happening more in 1DM. So we're looking at maybe repurposing IoT schema and using it to be an RDF interface to extend the modeling to physical domains. But we really don't have much participation. We have a W3C community group, but it's been dormant for some time. And there's a problem as I'm not in the org I was in, so I can't be the chair of it. We're not really extending schema.org anymore either. So I don't really have a forward direction for this, but just to get everyone up to speed that we're not really active right now, and but there are some proposals to use the name in the space to fill some other gaps in the industry. It's just no one really working on that right now. So that's really all I have. I'm not sure about the timing, and probably time for some questions, but mainly wanted to kind of bring up the stuff that we're doing in one data model going forward. Questions, comments? Audie has a hand up. Yeah, and also please fill in any gaps, what things that I have failed to explain.
Great. Thank you, Michael. Yeah, I was thinking of commenting perhaps the same I was asking for the previous presenters, like the best ways to get engaged. I guess like for the 1DM work, I mean, talking about model conversions, how we get to common semantics, etc. A 1DM liaison group is an open group, so just joining the mailing list, joining the meetings, I guess that's the best way forward. And then if you're more interested on the, let's say, IETF standardization aspects, the SDF, the language standardization is happening in the ASDF working group. And then for the more researchy topics in the wishing meetings, we have been discussing many topics related to 1DM and SDF. So I guess those three venues, at least to me, would be go-to places on this topic. Okay, any more questions or comments on this one? Okay, we're actually quite okay on time here. Thanks a lot for the update, Michael. And let's continue the discussions in those aforementioned venues. And then go ahead, Carsten, with the sworn Tina teaser.
Yeah, I didn't want to impinge on Juran's presentation of the new Secor work, but I have one item that has been lying around in the research group for half a decade now that has recently gotten new attention. So in 2016 to 2017, we did some research for a manufacturer of IoT devices where they wanted to put these IoT devices on the internet, but somehow needed to protect them from unwanted traffic on the internet, because that unwanted traffic would drain their batteries. So in particular, the wake on radio scheme that these devices were using, that needed to be very tightly controlled. And we came up with something we called SWAN, Secure Wake on Radio Nudging, which is essentially the yellow part in the picture, where we have a client that wants to talk to the device, and we have a last hop router. So imagine that the left arrow is much longer than the right arrow. And the last hop router is essentially the device's friend in the network. Or if you're not familiar with that terminology, you could call it a policy enforcement point. And that router only lets packets through that the device really wants. And this, of course, works by the device sending out grants, and the client can use this grant to generate a token, and that token is checked by the router. This was just a proof of concept. We did this and wrote it up in 2017, but didn't really want to push this through standardization in any way, because we thought this was just a scheme that was interesting to document. Now, recently, there has been renewed interest in this, and maybe in generalizing the concept a little bit, and actually adding roles to the model. And this is the white part of the figure, where we have authorization managers, which look a lot like the four-leg actor model that was discussed in ACE. It's not exactly the same, but some of the things are similar. So basically, the device no longer has to do everything on its own, like what was necessary in SWAN, but can delegate some of that to the device authorization manager, and the device authorization manager talks to a client authorization manager, which does all the necessary work to prepare things. So grants can be asked for by the client, and the grants can be obtained right from the client authorization manager, and then the client can compute a token, send it over the path to the router, which doesn't need to be a last hop router in this case anymore, because we are not only talking about wake on radio. Then we would have the router verify the token again and send the data onto the device, and possibly the token will be sent with that, because the device might be interested in doing some of these checks themselves. So we have more flexibility in putting the policy decision point somewhere. So what was in the device in SWAN can be in one or two of the authorization managers, and the authorization manager can also do the communication with the routers on the way. And what we are really interested in right now is two things. One, actually coming up with a protocol that can be efficiently executed by the routers. So possibly using something that is done using in-network computing, something that the COIN research group would be interested as well. So that's one layer of the discussion, but this is maybe not the interesting part for the Think2Think research group. The interesting part for the Think2Think research group is, did we get the right model here? Do we have the right players? So, for instance, is it a reasonable assumption that the client authorization manager actually talks to the policy enforcement point, or do we have to do this in the device authorization manager? So who actually has the job of protecting whom, and what information is exchanged before that can be done, and so on. So I think that's really the interesting part here, getting the right players defined, getting up processes, security workflows that can be run to make this happen, and of course deriving crypto from that actually can be executed by in-network computing. So that's where the two areas are linked. So the simple approach of having the client sign each packet obviously works, but we need very fast routers to make that happen. Okay, so that was just a teaser. I think we should have some more discussion about this, and we already have had some interchanges between Think research group people that we might want to work on this, but I wanted to make this more visible to the greater research group community.
Great. Thank you, Karsten. Any questions, comments? I noticed there was one comment from Mike McCool in the chat that it's somewhat similar to the mechanism in Z-Wave, although that one is more specialized.
Yeah, I wasn't aware of that, so that's a good input. Thank you.
Thanks, Michael. Okay, and I guess the follow-up discussions, thinking research group mailing list, perhaps Secore, is that's where the discussions would be happening going forward. Okay.
Thank you.
Thank you, Karsten, and thank you, everyone. I guess now we're actually quite nicely on time, exactly 1 minute over the over the planned time for the wrap up. So yeah, as mentioned in the beginning, this was one of the overview summary meetings that we have for the thinking research group, and then for the more detailed discussions we have in different forms, sessions, where they're working meetings, interim meetings, etc. So please do join those discussions when then they are usually announced on the mailing lists. And also, as usual, please do use the mailing list for the discussions between the meetings. That's an easy way for everyone to stay in touch. Okay, but that was everything we had planned for today. Any more final questions from comments for anyone before we wrap up for the day? Okay, in that case, thank you everyone for joining today. Let's stay in touch in the upcoming meetings. And for those of you traveling physically to IETF-113, good luck, and looking forward to see many of you soon face to face. Unfortunately, I won't be myself over there, but hopefully very soon again in these ongoing meetings. So with that, thank you. Have a nice rest of the day and see you soon.